Today's empowered presentation is going to cover proven applications with real world results. So, we're going to actually discuss some of the applications that we've hinted at in the past couple weeks, and we're going to get down deeper into the details of those applications. Talk about some of the things that you can have and experience with these. Most of our customers have been creative, as you'll see with a couple of the examples that we have. Everything that we discussed today isn't all the portal can do, but it's just some of the examples of things we have done and some of the more popular use cases we've seen with these applications. This is the third of our four-part series covering Empowered. So two of the things that we wanted to cover today before we jumped into the presentation are two terms that we're going to use pretty frequently throughout. So OEE, which I'm sure most on the call are familiar with, is overall equipment effectiveness. It is a value that allows you to identify your machine's productivity by simply measuring the quality, the performance, and the availability of the asset itself. So, is my machine running when it's supposed to be? Is it making as many parts per hour as it should be? And am I making a good quality batch out of the other side? These three numbers multiplied together will give you your OEE score and allow you to visualize the asset's health on a large scale. And this is a very common number that we've seen throughout the industry. It's picked up a lot of popularity in the last 10 years, but really is something we see many of our customers focus their metrics around, whether that be on the injection or the extrusion side. So it's something that we've geared the portal around to really help not only calculate that OEE, but focus on the quality, the performance, and the availability. And you'll see as we go through our applications here, you'll see that theme come through during our discussions. The second term that we're going to review before we jump too far here into the presentation is API, or Application Programming Interface. So everything that we discussed today, and I've got another slide here that kind of gets a little deeper into this, but everything that we're going to discuss today has a common theme of allowing you to grab information and utilize it and be a partner to systems more than a competition or a competitor and somebody that's looking to come in and replace an entire business system. So application programming interface is a handy tool that our system utilizes to pass data and handshake between different softwares or between different programs. So when we get to a couple slides deeper here, I'm going to go through a little bit of that and some of the things that we do to make this program as flexible as possible for our customers, for our partners. And it's, again, just a term you'll probably hear several times as we go throughout the presentation. So this first slide here again is our relational topic for this series. So we like to revisit this every week to kind of discuss what are the things that we're going to touch on this week back towards our relational item. So our relational topic, again, for those of you that are new or for those of you that listened to the previous 2 weeks, kind of centers around the car and the experience that has been created for drivers. So there are many tools, some of which we talked about last week, and some of the new additions that we're going to talk about this week. If you remember the picture last week, you may think this looks a little different, and it does, and it's different for a reason. And we're going to focus on some of these aspects, but really it's all about that experience that has been created through additional technologies that have been added to the car, other things that can read diagnostics from the car, and then also things that can pair with the car, such as mobile devices that have really made this experience much safer and much more reliable for someone that owns an automobile and needs to get place to place. So we're going to jump into today a couple of these relational items, such as the tools that are provided at a generic level that help you understand how the car is running. So when we look at things like fuel economy or speedometers or even your tire inflation numbers, these are very good indicators and tools that help you understand how that car is driving. If my fuel economy starts to go from a 38.2 down to a 37, that's instantly going to flag us. If it's in the winter and we're using the heat a lot more than other times, maybe it's something we can easily explain away, but sometimes that number starts to drop because there are other issues with the car, or maybe we're not getting as many miles to the gallon out of the car. Maybe that's something we notice versus the fuel economy. All of these these things we've learned to rely on to make it easier to own these vehicles, to make it more accessible to service and support. And really, again, it is a lot of the things that we're trying to build into Empowered to create that same experience for our users and our partners. The other relational item we want to mention, if you're like me, you write things down often in your car's maintenance manual. So you keep a notebook that tells you when you change the oil, when you change the brakes, when you rotated the tires, and it really helps you keep track of when these things are due, when they're coming due. You'll make little notes about things you probably should have done differently if you had done them at that time, and it's very helpful for resale. It's very helpful for understanding when you need to go back and make those decision changes, or when you buy the next vehicle, it could even factor into that. So there's a lot of relational things that even go in with this, and we'll talk about some more next week in our additional presentations, and I'll kind of allude to some of that. But even just seeing these things and being able to track when they happen, what intervals you're doing them in, it's very critical to how you maintain the equipment and how you create experience with your car. So we've taken these same mindsets and built them into all the tools that we're going to discuss today. So please, as we go through the presentation, again, keep that in mind. Keep in mind this relational topic, and it really starts to kind of help understand how you can utilize the data and become a empowered user with this information and these tools. So again, before we jump into this, what we wanted to do was kind of take you through the data accessibility. And this is really where I hinted at the API and some of the things that we've done and built into the system so that our users can find it more friendly to their existing systems or to new things that they want to do and they want to build into the plants. There's a lot of people coming out of schools today with degrees on data analytics. There's a lot more people coming out with those type of degrees and that type of education over somebody that can work on the machine. So these tools are going to become ever more important. So with that consideration in mind, Milacron with Empowered has done everything that we can to make this system as compatible as possible. So you can see a list of the protocols that we talk, but the more important piece on the other side is that our device is very easily interfaced with through tools that exist in the platform today. So when I refer to the API, anything that we talk about today, you will notice a common theme that if we calculate it, if we pull it, it is accessible and becomes accessible through that cloud platform to you from day one. Nothing in this platform is hidden from you. Anything that we do, anything that we calculate, you have access to, and you can take that information, pass it to your business systems. It's a relatively simple RESTful API that if you have anybody from the IT side, they'll more than likely understand that term or have used it for some other system so that they can take this information and make it compatible very quickly with nearly anything. We've had customers pass data to MESs, pass data to ERP systems, pass data to even their maintenance system. So this portal is very, very flexible in its allowance for how you grab the information. We've already deciphered it. We've already made it accessible in a shot-by-shot format. It's very easy to pick up and take that information and pass it to other systems. As we move forward and advance this, we are working on additional ways to tag and grab this information from the machines themselves. So we're kind of morphing the system to the point where it allows more real-time connectivity, or as real time as we can get to that. But again, as we go through the applications today, please keep in mind that everything that we discuss, we build with flexibility for our customers in mind. So with that, today what we're going to discuss are the additional levels of advantage and essential that we have not yet gotten to as we left off last week. So last week we talked here in the technical support, which showed you the real life application of our technical support team and their ability to connect to these machines and remotely support them. From there, we want to build on that and show you some of the additional applications that allow you to focus on the machine data and use that to become a data-driven business that allows you to generate reports, act on certain items on the machine, and really get that next level of understanding into your OEE and some other things that may drag down those values. All right, so the first application we're going to jump to today is the Connect portal. So at a high level, the Connect portal is a very good visualization system for calculating and showing you your OEE. So if you're curious, is my machine up or down? How effectively is it running? It's as simple as a few clicks of a button or pulling up your mobile phone, clicking on the mobile app, and getting a display of all of your assets, whether that be the individualized machine, individualized extruder, injection machine, work cell components that are around it, pulling it up and saying, how is it operating? So we work on a way to automate the calculation of your availability, your quality, and your performance, and we display that very quickly in an easy to read format. From there are some additional things to this application that allow it to be a little handier, which we'll talk about in some of these other slides, where you can view some of the production information. But staying here at this high level, this is very good for your management teams or for when you're trying to support a third shift operation and seeing what are my machines doing. Is it in an alarm state? What may be occurring that I need to focus on? Because if I scroll down this list and we've got the system to such a point where I know I'm expecting a 85% plus OEE score, and I can scroll down through here and see that some of them are not, there may be some items on there that help you very quickly say, okay, here's the machines we need to focus on. Obviously, something's wrong here. Let's get in and take a look at this. So in a world of COVID, in a world where the sickness is around and we may not be able to have as many people on the plant floor, this is a great way to connect people to machine information to be able to see how their fleets are operating. And it's also a great way to grab this information and put it in an automated system so that you can have it available for your business system. So all these simple things that you see being calculated here, being pulled into the platform, you can easily take this data, pass it to those external systems, or keep it there for your review or your own internal dashboards for your team. Jumping forward, the next application we're going to talk about today, and then we're going to go through a use case, some of the use cases of these applications, is our downtime tracking. So most of our customers we've seen are familiar with some sort of downtime tracking. So this may seem like an application that really sits at home with a lot of our customers, where they have this in some form or fashion. They either write this down on a clipboard, or they very simply have a system that allows them to go over and push some buttons. So this system actually keys off of machine data. Are you in a continuous mode? Or if a machine is dated enough, we have ways of calculating that the machine is up and running, and it will tell you on a timestamp basis when the machine is down and when it went back into production based off of your unique schedule. So we build in a plant schedule, compare it to that, and any time that we see that machine drop out, we work with you to build in a customizable library of categories and codes that allow you to code that downtime and then go back and see what are the main reasons for my downtime. Is it changeovers? Is it some other type of issue with just not having the right things at the right time for the machine? Is it auxiliary equipment? It's really important to understand that. And as I'll show you here in the use case, it can start to even show you things just based off of the machine telling you when it's down that you may not have seen based off of somebody writing it on a clipboard. Some of the other things that I want to point out with this application, as we advance this, again, we know a lot of customers have some sort of downtime tracking in one form or another. We have built in ways to automate this process. So whereas customers have to continually go in, push these buttons, it can become pretty cumbersome. So we've actually came up with ways with our machines, and we're expanding this to previous generations as well, to pull these error codes and help you automatically assign these downtimes as well. So if it's key for you to not have your experienced trained staff spending a lot of time assessing these codes, it can be very critical to have that time back to work it and focus on other things, even focus on fixing these downtimes. So we wanted a way for you to take that machine information, let it automatically assign, and then let the system work for you. So there are ways to also automate this process so that you can take advantage of these tools and technology and use less manpower to support the system. As we covered last week, again, I said I'll make several references back to our previous slides. If you're interested in how Milacron is using this data, please, I encourage you go back and listen to week 2 and our technical support and our dream for what we're moving towards as Milacron and how we support our customers. We have a big section where we talk about the downtime events, how we're grabbing those, how we're calculating those, and how we're focusing on being proactive to our customer base as well. So the use case we have here for downtime tracking, this was actually our very first customer connected to Empowered back in 2014. We had a customer that was experiencing a large amount of time when it came to mold changes, color changes, or just simple things of getting things in place to keep the machine operating effectively. So even just having a container there to box the parts once they were done, it was an arduous task, and they were having trouble calculating all that. They would have their teams that were responsible for the mold maintenance or the mold changeover to write it down and say it only took us 45 minutes. I'm not sure why there was 4 hours of downtime. And the same with the people bringing the material, and the same with the people that were responsible for bringing the containers and the packaging. There was a lot of finger pointing on this wasn't our issue. Why are we doing this, and why do we continuously say this is our problem? So what their intent was to utilize the system to really get a handle on how their downtimes were being affected by these individual pieces. So they had their teams very specifically focus on a set of machines and say, we're going to categorize when these are down, when they're down for maintenance, when they're down because we're waiting on material, and we're going to figure this out. And utilizing the system in a 20-month time span, they were able to reduce changeover times by 64%. So that equated to a 10% increase in their OEE, or 300,000 more parts in that same 20-month time span. So utilizing this system and just being able to track something as simple as a breakdown of how long it's taking each of these sectors to perform their job, you could see a drastic increase, which equated to 2 more machines running for this team over that same time span. So there are a lot of things that this tool can help with that relate back to realizable numbers once you start actually putting teeth to here's when it went down, here's when it was back up, and here's what happened during that time span. The next application we're going to review is our production monitoring application. So this is an application that allows you to track minute by minute data from your machine. So being able to actually see what was it doing for the last 100 shots. I had a quality escape 3 or 4 hours ago. It's really critical for me to get back and say, was it set point changes? Was the machine misbehaving? Was there something else that I'm not seeing that could have pointed to or helped me differentiate and potentially alleviate this quality issue? So this system is all about how do you track that information, put it in a usable fashion so that users can quickly digest it and go back and trace problems, and then help them set report or set alerts and understand when those processes start to deviate. So if it's something even maintenance related, if there are certain things with your motors that you don't like them operating over a certain temperature, it's very easy to go into the system, go back and track and do analysis on normal standard operating ranges, and then go into the system and set an alert for my servo motor 1 at 220 degrees Fahrenheit. This is the threshold and this is where I expect it to run. If it gets over that, I probably have an issue. Or my cushion needed to be above or right at half an inch. If it goes off by zero point 0.1 inches one way or the other, that likely means that I've got some sort of issue or I'm going to have a quality escape. With this system, it becomes very possible to take all that data, put it into this repository, and then have it there for studies. And again, everything in here is completely accessible through the API system, the same API system, to allow you to grab that information that's already been processed, already been in a shot-by-shot format, and put it into those systems. So if you have a quality system, if you have a maintenance system, and you want to take this data and pass it through, it is very easy to grab this and push it into those systems. Something that's also a common theme is we also have a lot of reporting mechanisms out of the system. So if you want to track your OEE that we already discussed with the Connect portal, and you want to relay that with your downtimes and your production stats, you can have automated reports sent to your team every day, every week, every hour, how often you need to see them, to help track these and make sure that things are staying within specific limits. So a very, very good system for helping you track production, making sure you have that data historian on your side for quality escapes, and really opening up your world for eventual studies on potential ways to alleviate these downtimes altogether in the future or these quality escapes altogether. For our use case for this application, we selected one of our medical customers that was experiencing a bit of a quality issue. And specifically, they actually had in one of their bottles a specific issue that their vision system could not always catch. So this would sometimes result in a quality escape of a certain type of product that they were making, where their quality teams would catch it before it got out the door. But again, it would cause a lot of time, and then you'd have to go back and assess the whole batch and make sure that you're getting the same group that was made together and putting quality things in place to do that. Whereas they're taking it a step back and saying, how could we make sure those bottles never reach that point? It's great that we caught them. It's great that they didn't make it out the door, but how can I free up that labor force to focus on more critical things? And by having this thought process, they were actually able to study the machine data, and every time they saw this particular type of failure, were able to detect a pattern with three specific variables that allowed them to see if these changed in this form or fashion, that meant that this product is likely going to experience this same quality defect. This specific customer actually took that information and then passes that down into an internal system and actuates a diverter that allows them to push these products back into a recycling bin so that they can take it and regrind it and get it to a point where they can reuse that material in some additional process down the road. But really, it's all about making sure that they caught that quality issue before it ever became a problem for their downstream team. So a very good way to take this system, study the data after the issues, and then put something in place so that you're preventing it altogether. So again, saving this customer valuable resources and valuable time just by having this diverter in action based off of real live machine data. One of the applications we wanted to bring to the table here today as well, it wasn't necessarily mentioned on the pyramid. This is something that we work with our customers on a piece by piece basis. This is a natural progression of the production monitoring application. So this kind of takes it one step further, where most of our customers have ways of tracking SPC or tracking their process on the machine. It's very helpful, we learned, to also have that same process and that same mindset in the cloud. So it helps when you have the ability to see what's going on for a third shift person that might be experiencing an issue, and it says, okay, well, I've got these 10 points, my cushion, my temperatures, my transfer pressure, or on the extrusion side, my torques, my speeds, something, my die zone, something in that area. And if it varies out of any of these certain set points or actual readings, chances are we're going to have a problem. But most of our experienced technicians know that when one of those varies, where to go to fix it. It's usually a setting, or some of the material might have changed from batch to batch, and it takes a certain tweaking of a set point, but there are still certain set points and variation that you allow for your technicians to account for this. And it's very critical for them to see this to provide an accurate recommendation. So again, in a world where a sickness is around, this is a very helpful tool for your expert technicians to be able to, one, recommend what you should do, or what the people on site could do, but then also track it real time and see real time changes to this recipe, where it's great on the machine, and the machine may flag you, but if somebody's not standing there, you won't catch it. This can send you a text message or email alert based on a priority 1, 2, or 3 item, and flag your level 1 or your master technician to say, you're having a cushion variation on this machine, you need to get out and look at it. So this is a very good tool. And again, we have a snapshot here of something one of our customers that uses this does today, where they take this information, they track it, they look and set a high and low limit, a target value as well, and they can see if those values get targeted, what value targeted it, when did it happen, who acknowledged that it happened. My dashboard all of a sudden lights up yellow anytime any one of these instances happen, or my cell phone lights up with a different color for that or for that specific asset, letting me know that there is an issue with that machine. We've learned that most of our customer base sees this as something that is very critical to track, not only on the machine, but also in the cloud interface, and then have reports on it to help you understand when it changed, why it might have changed, and which batches for quality concerns we might need to look at and analyze. The use case that we selected for this was actually a customer that had a lot of these same similar problems, and they actually put something in place where they have somebody go validate each of their processes every hour for each machine in their plant. So you can see that that would add up to a lot of time spent flashing through screens, even in this case, flashing through work cell components and saying, are all of my things within spec? And literally, it's somebody's job and one team's job to make sure this happens. And if not, they have to go out and try to remedy it. So what we've done is we've worked with them to put this application in place, track it, show them if it changes, and then from there go back and if something does change, get them notified so that they can go out and perform proper training for the technicians that are changing it, because usually it's a training issue. It's not somebody doing anything malicious. It's just, hey, our person needed more information than they had at this time. So it's a very handy tool for taking the clipboard out, monitoring your process, and making sure that it is staying in a desired state for the duration of the process. So with that, I'm going to turn it back over to Janice to see if any questions came in.
Hi, Eddie. I have a question from Matthew. He asked, what makes a productivity historian intelligent?
Historian, if you're grabbing data real time from a machine, it doesn't know without you telling it when to collect that information. So certain temperatures, certain pressures, certain speeds, you care about those at certain points in the cycle. And it's very important to capture those at the right time in the cycle, or it's going to paint a completely different picture. Our historian, in using our machine information, it takes care of all of that, and it basically gives you, here is our industry experience combined with these data points to say, here is the real picture of what happened on this point in time for that shot for a machine. So we combine our industry knowledge with the ability to collect data to give you a real intelligent tracker of your shots, of your data. And then from there, it also alludes to the tools that we give you to help analyze it. So there are tools in the platform that allow you to go back in time, see all of those shots, trace them, find the standard deviations, and really focus on what are some things, again, as I used the quality defect with one of our customers, what are some things we may be able to put in place alerting wise that will tell us if these change. So if my max injection pressure, every time it goes off 1 sigma, I need to flag my team because that means there's a quality defect. The system puts the tools in place for you to be able to calculate that value, put an alert in place, and be notified if it's going to happen a second time.
Thank you, Eddie. Tony asked, can you talk about how recipe insight could be used to optimize recipes?
Yes. So Recipe Insight also combines that same mindset. So where we have customers that we've worked on a report back to us that says, here is the highest quality output of our machine. So when we're getting good feedback that says this is the recipe that makes good quality, or on the other side, this is the recipe, this is the set of points, this is the machine readings that mean I'm making a bad part. We take that information, and without you having to go to some other huge platform, you can go back into the system and say, if I have a quality report, I want to click a button that says, give me all the optimized settings that you've calculated in the system of when the machine performed it at its best. So it's very good at understanding and taking that information and relating it back to that quality metric. So the quality metric, as we make that more automatic, and if you have a set of 10 KPIs that tell you that a part's good, that's great. But if that goes all the way down to a vision system that tells us one way or another that a part is good or bad, we take that feedback and then use that to analyze and optimize and recommend a certain group of set points to put into the machine to get the highest level of quality.